apparent depth. Now it is a common observation that the bottom of the tank filled with water appears to be raised when seen from air medium. That is, when you are seeing from the air medium, you can see the bottom of your tank is appeared to be raised. Okay. Now this is the real depth of the tank. Okay. Now it is seen to be raised to this distance. So we call this as the apparent depth. We call this as the what? Apparent depth. So now we are going to derive an equation for apparent depth when we are viewing from the normal direction. Now light from the object which is at the bottom of the tank. So this is an object which is at the bottom of the tank, passes from denser medium. So this is the water is the denser medium to the rarer medium to reach our eyes for viewing the object. So the light is traveling from this medium to this medium. So what is happening here? The refraction will take place. Now the light deviates from the normal. So here this is a normal. Now light from the object is passing from the denser medium to the rarer medium. So the light deviates from the normal in the rarer medium at the point of incidence. This is the point of incidence in the rarer medium. Now here N1 is the refractive index of the denser medium, that is the water, and N2 is the refractive index of the rarer medium, that is air. Okay. Here N1 is greater than that of N2. Now the angle of incidence in the denser medium. So here this is the angle of incidence. So the light from the object O, it is incident at the point here. So this is the angle of incidence. So the angle of incidence in the denser medium is I. And this is your angle of refraction. The angle of refraction is taking place in the rarer medium. Okay. Now here these two lines, that is N dash and OD. So these two lines are parallel. Okay, N dash and OD are parallel. So since this angle is R, we are extending this line and this angle is also what? R. Okay, so the angle DIB is also what? R. Okay. Now we are considering, that is, the angles I and R are very small. Okay. So as the light is entering from the denser medium to the rarer medium for a normal view. So we are considering the angles of incident and the angle of refraction as very, very small. Now from Snell's law, we can write sin I by sin R is equal to N2 by N1. So we can write it in the product form as N1 sin I is equal to N2 sin R. Sin R. Now I told angle I and R are small. Since angle I and R are small, okay, now we can approximate them as sin I is approximated as tan I and sin R is approximated as tan R. So I can write the above equation as N1 tan I is equal to N2 tan R. Now I am going to take the triangle DOB. So this triangle I am taking DOB. Okay. So what is tan I? Tan I is opposite side by hypotenuse. So for I, the opposite side is DB. DB by, here this is the hypotenuse. So it is DO. Okay. So I am going to take the triangle DOB. So this one I am taking. Okay. So this is I. So here it is DB by DO. So I can write tan I is equal to dB by DO. That is in triangle DOB. Okay, so in triangle DOB, tan I is equal to dB by dO. Now I'm going to take the next triangle DIB. So this is DIB, this small triangle. Okay, so what is tan R? Tan R is equal to dB by DI. dB by what? DI. In triangle DIB, tan R is equal to dB by di. Now I am going to substitute for tan I and tan R. So N1 dB by dO is equal to N2 dB by di. Okay, so we can cancel dB on both the sides. Okay, so I'll get it as N1. What is dO? Here it is dO is d and di is d dash. dO is what? D and di is d dash. So I can write this as d N2 by d dash. Okay. So this can be written as N1 by d is equal to N2 by d dash. So we can write d dash by d is equal to N2 by N1. So what is d dash? D dash is equal to N2 by N1 into d. Now for rarer medium, we are taking it as air. So for air medium, N2 is equal to what? 1. The refractive index N2 is equal to 1. And denser medium, I am taking it as N1 is equal to N. N1 is equal to what? N. So I can write d dash is equal to, for N2 it is 1. So it is d by N. Okay. So this is the apparent depth, we have got it. So the apparent depth is what? D dash is equal to d by N. Okay. Now the bottom appears to be elevated by d minus d dash. Now this is the original depth, this is the apparent depth. So this is the depth to be elevated. Okay, so this is d minus d dash. So we can write d minus d dash is equal to d minus d dash is what? D by n. Okay, so that is d minus d dash is equal to d into 1 minus 1 by n. Okay, so this is the height which is elevated. Okay, so this is the equation for the apparent depth. This much height, it was appeared to be what? Elevated. Okay, so we have derived an equation for apparent